Hi, this is View. Today I'm gonna review some key points of the module AMEM2085 Data Bus and Logic. Here's my notes take from this module. In this class, we learned the digital number system like binary code system and binary coded decimals, logic gates, microprocessors, computer operations, aerodynamic radio incorporated, and measurement of logic levels. And here's some details that we learned. We learned what is the digital signal and the difference from the decimal, and there are only two distinct values, which is 0 and 1, just two values, and it's different from the analog signal, which contains an infinity number of voltage values like the watch, altimeter, pressure. They are all analog signals, but digital signals just the 1 or 0. And the binary number system, two components, just 1 means the high value, 0 means the lower value in the positive way. And we learned the bit means 1 bit equals 1 binary digit, and 1 digit means 1 decimal digit, and the byte used for the bits group, which contains 8 binary digits, and the word, it's a group of bytes that computer uses as the standard information format. And also we learned 3 the most common system used to produce the faster computer, which is the BCD decimal, octal notation, and the hexadecimal. A binary coded decimal, which is BCD, uses a group of 4 digits to represent each digit of decimal number. An octal notation is a binary representation of an octal number. It's composed of 8 different symbols. Hexadecimal number system uses a base of 16. And next we learn the gray codes, which doesn't change 2 or more bits at once. It's an unweighted code. And then we learn the logic gates. There should be 7 fundamental logic gates, which is AND gate, OR gate, invert gate, NOR gate, NAND gate, XOR gate, XNOR gate. The AND gate, it's a situation where outputs must be 1 to produce 1 output. OR gate, where any input is 1 will produce 1 output. Invert gate is also named as a NOT gate. It will convert the input. Like the input is 1, the output is 0. If input is 0, output is 1. Just revert. And NOR gate is a inverted out gate with a OR gate. Any input 1 will create 0 output. A NAND gate is the AND gate with the inverted output. Any input being 0 will create 1 output. XOR gate, XNOR gate is similar. The difference is that XOR gate produce 1 whenever either of the signal is dissimilar. And the XNOR gate will produce 1 if the input signals are similar. They are opposite. And then we learn the positive logic, negative logic. Also, we learned the definition of integrated circuit, which is a simple assembly of diode, transistors, and circuit elements combined into extremely small packages. And there are not two families of logic, which is TTL and CMOS. TTL stands for transistor logic. They use the bipolar junction transistors as the primary element, and positive 5 volts power indicates the high value, and the high value 1 is from 2.6 to 5.0 volt DC, and the 0 voltage from 0.0 to 0.8 volt DC, and the CMOS is the complementary metal oxide semiconductor. Use a metal oxide semiconductor field effect transistor using both P and N channel inputs. The standard of the logic circuit is the dual inline package. Acronym is the DEEP standard. There's a kind of surface mounted component, which will the components are bent at 90 degrees, which allows the component to sit flat on the printed circuit board, and this surface mounted component can along double side of the PCB to installed with the integrated circuit, not just the one side. Deep circuit is the common which is used to computer and logic circuits. The gates of the category of logic circuit are combination logic or sequential logic. Combination logic includes the adder and subtractor, and sequential logic includes the latches and flip-flop. And there's also a clock. It provides a stable frequency for binary 1 or 0 in the form of a square wave. And inside the component, there's a crystal material to provide the stable frequency. Next, in the microprocessor, we learned the CPU circuit. It's the CPU circuit within the computer carries out the instruction of the program performing the arithmetic logical input-output operation of the system. And if the memory, clock, CPU act are contained in one same chip, the CPU will be considered a microprocessor. And synchronizer or clock circuit in the timing device use to coordinate activities of system and data exchange on the buses. There are three types of the information buses, which is control buses, address buses, and data bus. And the computer operation, there are 5 components, which is input, output, also as known peripherals, and the CPU, which contains 3 components: CCU, memory, and ALU. The computer operations as the input-output is the peripheral that provides a computer a means to communicate with humans or other electronic devices. The CPU, central processing unit, is the circuit within the computer or computerized device like a cell phone that carries out the instruction of a computer program by performing the basic arithmetic logic input-output operations of the system. 3 essential subsystems of the CPU is the CCU, memory, and ALU. If these 3 components is combined in one component, and this CPU will be considered as the microprocessor. And there are 2 kinds of memory in the CPU, volatile and non-volatile. And the semiconductor memory, it's no moving part and more reliable source. improving flight safety. And RAM and ROM, two kinds of memory, which is one is the volatile, one is non-volatile. And then we learned the data transmission two ways, serial or parallel. And we learned several kinds of data bus standard and Array Inc. ARINC stands for Aeronautical Radio Incorporated, and some common ones are Array 429 and 629. And then we learn the difference between the 629 and 429, that in 629 it will save lots of weight than the 429 because it's a bi-directional serial data bus, and the 429 is just the unidirectional data and one way. Both of them are twisted shielded pairs. And then we learn how to measure the logic level, use the logic probe or logic monitor. Logic probe just measure one point in the logic circuit, and the logic monitor will connect each end of the integrated circuit to measure the logic level. That's it. Also, we learned the HERF, and the ESDS. HERF stands for the High Energy Radiated Electromagnetic Fields, and electronic static discharge sensitive component. The logic component is very sensitive to the static electricity. So that's it. Thank you very much. And this is for the module of 2085 data bus and logic.